Good day. This is just a class assignment solution for the Maruf InfoSec networking student, not the security student. This is for the networking student. So I'll start by going to my core switch. Here's my core switch. Enable, going to config T, configuration mode, host name, core switch. And I'll create my VLANs there. VLAN 10. Okay, I'll not create VLAN 10. I'll create VLAN 11, VLAN 12, VLAN 13 sales, and the native VLAN and the black hole VLAN. Then I'll create VLAN 999. I'll name it black hole VLAN. Where is it? So let me end the configuration. Show VLAN brief. I have my VLANs, VLAN 11, 12, 13, 14, 99, and 99 for my black hole VLAN. So I'll do the same thing on all the other switches. Let me go to my access switch for one. I'll go to my server switch, access switch. Then I'll go to the spine leaf core switch. Next is for me to configure my trunking ports and then to configure my native VLAN, then to prevent my no CDP run, then my spicy tree. So on the interface, this is my switch 3, my server switch. Then I'll go to this core switch 2. The interface range is FA1 or 2. Then these are going to be applied on the trunking ports alone. And then my core switch. I'm already getting mismatch interface range FAO1 to 7. 1 to 7. So show interface trunk. Show interface trunk. Now I have my native VLAN 99. My interfaces are carrying all this. I have interface 2. I have 1, 2. Okay, 1 is not up yet because I have not configured the link to the router to my core browser. Yes. So VLAN 99 prevents VLAN hopping with default VLAN 1. So now I've done my VLAN filtering to allow my required VLAN 2. So I'm going to configure my EtherChannels. So I'll start with my access switch. Interface trunk. Okay. Now I'll configure interchannel between these two interfaces, FA1 and 2. Okay. Good on that. I'll go to this. I'll do the same thing with my interchannel. And this one to configure my interchannel. Then my interchannel will be configured between Yeah, I made a mistake earlier to put this on port channel 1, but I've corrected that by changing it back to port channel 2. Yes, it's on port channel 2. So I'll put this link on port channel 3 link. So that's what I will do. This interface. Okay. The channel group 3 mode stay active. Is it then the interface port channel 3. Then now apply the switch port mode trunk on that port channel 3. Show EtherChannel summary. Now is on 3. Okay, I'll remove the 1 later. Now I've configured my EtherChannels and I've configured my trunk. Show interface trunk. So I will go to this interface too. This is switch 6. This is summary. This is port channel 1. This is on port channel 2. Okay. So interface F45 will be port channel 2 too. Interface range FA0 5 to 6, 4 to 5 rather, 4 to 5, 4 to 5. Big T. Interface range 4 to 5. 4 to 5. Switch port mode trunk. And channel group 2. Modes. I'll make it active too. I can do active or active passive. I can't do passive passive. Because it's in interface ports channel 2. Then I will now trunk it. But show interface trunk. Show EtherChannel summary. Okay, I have it there. So on the last link, go to my configuration mode, interface range FAO 6 to 7. Make it a trunking parts. And add the VLAN filtering to it. Then the channel group will be 3. Mode active. Exits. Then interface ports channel 3. Now add the trunking the native VLAN on it. And the VLAN filtering. Now I've configured these. So now let me go to my core. Do my interfaces and enable my routing. So I've configured my router interfaces. Okay, just left for my ISP router, my T-Mobile. Go to that one. So go to interface Java 0/0 IP at 100.100.255.255.255.0. No shots. Exits. IP has 8.8.8.1. 255.255.255.0 shots. Okay. So I'm going to enable OSPF as a routing protocol. Be the subsequent video, we're going to do route distribution for our T-Mobile, but now we are going to do OSPF for all the routers. So I'm going to enable OSPF as my routing protocol. So I've enabled OSPF in this topology. So now I did my EtherChannels, I did my VLAN filtering, I did my native VLANs, no switchboard negotiates, spline tree was applied on the trunking ports. My routing protocol has been enabled. So the next thing is for us to configure our sub interfaces. So I'll go to my WAN router. I'll configure my sub interface. I'll go to my spine and I'll configure my sub interface. But let me first focus on my core router to enable my sub interface, this configuration. So interface, I'll name it 11 and 13. So I'll go ahead and configure my sub interfaces. I have my VLAN 11.12. VLAN 11 is going to use 11.1. VLAN 12 we use 12.1. And I'll also configure VLAN 99. And I'll also configure my native VLAN, which have been moved to 99. The configuration is quite different because I have to add encapsulation.1K to it. That is how to configure your native VLAN as your sub interface. You have to add encapsulation.1Q99 to it because that's your native VLAN. You're telling the switch that this is my native VLAN. I'm still returning to my native VLAN. Why is it important for us to do this? It depends on how you want to handle your own configuration. It depends on how you want to handle your own configuration. If you are using your VLAN 99 as your native VLAN on the trunk, which I'm using, it's strongly recommended to configure your Gigabyte 0/0.99 as your native sub interface on the router. When that router link is doing route on the stick, that means trunk to the switch. If you want to manage the router, which we are going to do, and our switch is using VLAN 99 as our my VLAN. That means we are going to configure our SVI VLAN 99, and our default point is going to be 99.1. Then the router must have an IP in VLAN 99 on the route. So you understand now that our trunking use native VLAN 99, and we want our router to correctly handle the untagged frames as VLAN 99. That's exactly what we did by configuring encapsulation.1q99 native does. Based on this, our topology, we want to SSH into our environment. We want SSH from the remote worker into the core and the access switch via VLAN 99 management IP. Router needs to route so that VLAN 99 will handle its own gateway. Sometimes it's not necessary. If you want to skip gigabyte 0/99, that VLAN 99 is only being used as your native, that means on tag. No devices actually live on VLAN 99. You are not assigning switch management IP on VLAN 99. You don't need inter-VLAN routing or reachable to VLAN 99. So it depends on what you want. But in real labs, VLAN 99 is actually both our native and management. So it's very useful. That was why I saw me doing this configuration. So it depends on what you want to do. I've updated my routing table with my VLAN 11, 12, and 99. And I also configured my default routes pointing to my WAN. So on my WAN router, I'm going to enable my paths. PT interface gigabyte 0/0 IP NAT inside exits interface gigabyte 0/2 IP NAT inside exits interface global/1 IP NAT outside exits. So access list 1 permits the whole of my network. 168, I'll make it /16 network 0.0.55.255 IP NAT inside source list 1, referencing my access list, then interface gigabyte 0/1 overload. That's my IP NAT outside. And WA. So before I enable my DCP, my DNS email with configuring my access list to permit the required traffic, I just want to do a manual test. I assign this device static IP address. Please remember to configure to move the interfaces to the rightful access ports configuration, please. So now let me try to ping is default gateway 192.168.11.1. I can get this default gateway. Now let me try to go outside my 8.1. Okay, my routing is good. So now let me try to ping my Google server. Ping my Google server. Now I will also try to browse into my Go server. I'll use HTTPS 8.8.8.8. I can go through. Let me use the other device to do the same thing. This, I'm going to use HTTP for it. HTTP 8.8.8.8. Now I can get there. Now let me go to, I want to see the show IP NAT translations. Now, okay, my NAT is working. This is a PRO stand for protocol. The first protocol I issued was ICMP request. So it's been translated to single interface here parts. As it's getting this port, this is source port, and it's going to the outside 8.8.8. The second time I do this protocol, TCP protocol, being translated to this inside global, the same interface, as it has been assigned another port, source port, and it's going to port 80, which is HTTP. The second one was the same, it's been translated to the same port, 100.1, my gigabyte 0/0, and assign a different port. That is why it's called port address translation. So every section will have its own source ports. And these are our destination port 443, our destination port HTTP 80. You can see for every section, they have their own source port on it. And all of them are using the same interface IP. So many to one we just did. So this is the part one of the configuration. So I will send a part two after this. Thank you. Bye.